All right, so let's find Taylor series for f of x equals e to the 3x centered at a equals -1. Yeah, so you can center this up at negative values just as much as you can at positive values. Let's see what this one is. All right, so again, we're gearing up towards that Taylor series formula. N equals 0 to infinity, nth derivative at a over n factorial times x minus a to the nth. So we want that, if we can, get a formula for that nth derivative at a, which in this case is -1. So let's work on some derivatives. Start here just by getting some derivatives. F of x equals e to the 3x. First derivative would be, well, just a little chain rule, isn't it? The derivative of e to a power is just e to the power, but by chain rule, you got to multiply by the derivative of the exponent. So that's 3 e to the 3x. Second derivative then would be that 3 e to the 3x, but then you got to multiply by another 3 because of another chain rule, right? So that's 9 e to the 3x. And so third derivative would be 9 e to the 3x times another 3 because of the chain rule, which is 27 e to the 3x. And maybe we got the general feel here, but let's do one more. All right, so then you got 27, so that would be 27 e to the 3x, then by times another 3, so you got 81 e to the 3x. Now evaluate those at a equals -1, or x equals -1, so that would be f of -1. Well, it's just going to be e to the -3. Then f prime at -1 would be 3 e to the -3. Second derivative at -1 would be 9 e to the -3. I think 27 e to the -3, and then fourth derivative, 81 e to the -3. So in this one, for the nth derivative then at a, or -1, what do we got? Well, they all have e to the -3 in them. One thing they don't have, we don't have the alternating signs here on this one. So they won't always have alternating signs. But what about the other parts here? Yeah, those are powers of 3, aren't they? 3 to the first, 3 squared, 3 cubed, 3 to the fourth. And notice it's matching the nth derivative, so matching n. That's 3 to the fourth, so we're talking about n equals 4. This is 3 cubed, and we are talking about n equals 3, which is the second derivative. Yeah, so it's 3 to the n. That would be our nth derivative of a, so our f of x is e to the 3x, so it's going to equal, oh, does it work for all n? Is that going to give me the right thing for that one? That's n equals 0. Is that going to give me e to the -3? Yeah, 3 to the 0 is 1 times. So it works for all n. So I don't have to make any exceptions here. We can just do n equals 0 to infinity. The nth derivative is 3 to the n, e to the -3, over n factorial. That's part of the formula. And then x minus a, the a is -1. Oh, so if I do a minus -1, it's going to wind up being x plus 1. So, and I don't think there's any simplifying to do there. I mean, again, one thing they might do, since both of these are the nth power, go ahead and, what would it be, 3x plus 3 to the nth? They may do that. I don't know if we do that or not, but they might. Be aware. Now, the other part to this is the radius of convergence, interval of convergence. It's interval radius too, but well, if it asks for the interval of convergence, you're just going to use ratio test in most cases. Do your limit as n goes to infinity. I think that's what it has. I'm sure. Radius convergence. What is radius convergence? Either one. Okay. Either one you'd still use ratio test. All right, so remember you're going to use the limit as n goes to infinity of the n plus 1 term divided by the nth term. And so in this case, we wind up with the n plus 1 term would be 3 to the n plus 1 times e to the minus 3 over n plus 1 factorial. Times x plus 1 to the nth plus 1. And let's just go ahead and put that up here with this. That would be the n plus 1 term, then divide by the nth term would just be the reciprocal of that. So the reciprocal of that, again, the n factorial will be the one on top, and then the rest will be the denominator for that. With me there? So what's going to happen? Well, that 3 to the n is going to cancel that 3 to the n and leave me a 3 to the first. That x to the n plus 1 to the n is going to cancel that out and leave me an x plus 1 to the first. And then, again, this n plus 1 factorial will be n plus 1 times n factorial, without having to write this all again. That's going to cancel out. And that's going to leave me e to the minus 3. Oh, no, the e minus 3 cancels out too, sorry. 3 on top over n plus 1 times x plus 1. Leaves what's left, right? Checking on that, but I believe that's all that's left. Well, as n goes to infinity, what does this do? That goes to 0, doesn't it? Just 0. Now, what does that tell me? That's one of our special cases. When we get this limit equals 0 for these, that's always less than 1, isn't it? So the radius of convergence here would be infinity, right? So, yeah, just pull, they won't always be infinity, but how's that? Okay?